See, classification of molecules based on moment of inertia. See this first point, a molecule can rotate about an axis passing through its center of gravity or center of mass. For example, take this HCl. This is the center of mass. A molecule can rotate in 3 directions. Suppose X, Y, Z anukondi. A molecule can rotate in 3 directions. So, if you are rotating along x-axis, the molecules will try to resist that force. Avuna mana chadukunnadi ade kada. What is moment of inertia? The resistance strength of a body to resist the motion against the applied force is called moment of inertia. Avuna? So, if you want to rotate a molecule along x-axis or a-axis, it tries to resist. See this molecule, HCl molecule. This is like x-axis, but we are showing with the A, and this is B-axis, and this is C-axis. And A, B, C, these axes are perpendicular to each other. Here you can see this molecule. And this is like x-axis anandi. Leda, here we are taking A-axis. And this one is B-axis. And here this is C-axis. And these 3 axes are perpendicular to each other. But these A, B, C, these 3 axes are passing through the center of gravity. For example, A axis patkoni alla meer rotate cheddam anukunnaru anukondi. Emotundi? Generally molecules will try to resist the movement. Avuna? That is called moment of inertia. So, if you want to rotate this molecule along A axis, along B axis, along C axis, there will be 3 types of moments of inertia. Moment of inertia along A axis, moment of inertia along B axis, moment of inertia along C axis. If you want to rotate the molecule along this B axis, again it tries to resist that movement. So that is moment of inertia along B axis. So a molecule will have 3 moment of inertia. Any moment of inertia untai mari? 3 axes తీసుకున్నాం కదా. కాబట్టి molecules will have 3 types of moment of inertia. That is IA, IB and IC. Based on these IA, IB, IC moment of inertia, molecules are classified into 4 groups. Number 1, linear molecules. Next, spherical top molecules. And 3, symmetrical top molecules. And number 4, asymmetric top molecules. Let us see. The first one is linear molecules. For example, linear molecule HCl. Horizontal line చూడండి ఇక్కడ. This is A axis, okay? A axis ఎలా వెళ్తుంది? హైడ్రోజన్ ని క్లోరిన్ ని టచ్ చేసుకుంటూ వెళ్తుంది. See, this axis is passing through hydrogen and chlorine atoms and through center of gravity. That is why this is called molecular axis. You are rotating HCl molecule through this axis. Rotate చేస్తున్నాము అంటే molecule will try to resist that acceleration or that motion. Avuna? But here, see this, you are trying to rotate this HCl molecule along A axis. Appudu HCl molecule em chestundi? Molecule will rotate. Yes, rotate. But the position of hydrogen and chlorine atoms will not change. Ide manam ninna cheppukunnam. Sarele edo rotate చేస్తున్నారు, నా ప్లేస్ లో నేనే ఉన్నాను అని హైడ్రోజన్ అనుకుంటుంది. నా ప్లేస్ లో నేనే ఉన్నానులే సరే తిరుగుదామని చెప్పేసి క్లోరిన్ అనుకుంటుంది. So there is no change in the position of hydrogen and chlorine atoms. So that resistance strength will be negligible. పెద్దగా రెసిస్ట్ చెయ్యవు because positions are not changing. Kadamma. Axis is passing through hydrogen and chlorine. Ade axis lo hydrogen akkade undi, chlorine akkade undi. But just you are rotating. So that is why moment of inertia will be negligible or 0 along A axis. For HCl molecule, IA is equal to 0. Here you can see, when the molecule is rotated about the molecular axis, the relative position of atoms do not change or very slight variation can occur. That is why moment of inertia IA is negligible, or you can say it as 0. Now you are rotating this HCl molecule through this V axis. Vertical line చూడండి. And remember, V axis is also passing through the center of gravity or center of mass. అక్కడ నుంచి వెళ్తుంది compulsory. Rotational axis will pass through this center of gravity. Now we are rotating HCl molecule along this B axis. Okay. Now, what is the expected moment of inertia? It will be equal to 0 or it is not equal to 0. What will happen?
Not
Guess
equal to 0.
why? Of inertia
Because
is
the
not.
position will change, ma'am.
Okay, if you IB, moment of inertia along B axis will not be equal to 0. ఎందుకు అంటే పొజిషన్స్ ఆర్ చేంజింగ్. అయ్యో నా ప్లేస్ చేంజ్ అవుతుంది అని చెప్పేసి అది వద్దు నేను వెళ్ళను అంటుంది. బట్ వీఆర్ రొటేటింగ్ త్రూ బి యాక్సిస్, తప్పదు కదా, వీఆర్ అప్లయింగ్ ఫోర్స్, సో ఇట్ ఈస్ రొటేటింగ్ అండ్ దట్ పొజిషన్స్ ఆర్ చేంజింగ్, అవునా? సో దెర్ ఈస్ సమ్ రెసిస్టెన్స్ స్ట్రెంగ్త్ along B axis. So that is why along B axis IB is not equal to 0. Very good. And now see this C axis, and again you are rotating this HCl molecule along this C axis. What will happen? Moment of inertia will be
is not equal to 0. Moment of inertia is not equal to 0. IC.
very good. IB is not equal to 0 and IC is not equal to 0 because rotation about B and C axis causes change in the positions of hydrogen and chlorine atoms. For linear molecules, IA is equal to 0, IB is not equal to 0, IC is also not equal to 0. That is why IB is equal to IC, that is not equal to 0. Okay, next. Number 2, spherical top molecules. What is the name of this molecule?
Methane.
Very good. Methane. Okay. Methane. Center of mass is located at carbon. Why? Because of this symmetry. Because carbon is surrounded with 4 hydrogen atoms. Carbon chuttu anni hydrogens e unnai. There is no electronegativity difference. And carbon is with high mass. That is why center of mass is located at carbon. Okay. Now, just imagine 3 rotations along A axis, B axis and C axis. Okay. Now imagine 3 rotational axes, A and B and C. A axis, చూడండి ఇక్కడ జాగ్రత్తగా అబ్జర్వ్ చేయండి. Just imagine a line is passing through hydrogen and carbon. So 3 hydrogens left. ఫ్రీగా ఏమున్నాయి, ఎన్ని ఉన్నాయి అక్కడ? 3 hydrogens. And now rotate this molecule through this A axis. What will happen? Can you observe any difference in the position of hydrogen atoms? See, rotate this methane molecule along A axis. Okay, here imagine this axis is passing through carbon and this upside hydrogen. Okay, carbon and hydrogen nundi oka line పోతుందని ఊహించుకోండి. And try to rotate this methane molecule. Then the positions of these 3 hydrogen atoms will
Change, ma'am.
yes, the 3 hydrogen atom positions will change. So every molecule will resist to applied force. అవునా, మనకు తెలిసిందే. మీరు ఎప్పుడు రొటేట్ చేసినా కూడా మాలిక్యూల్ ఏం చేస్తుంది, తిరగను అంటుంది, అవునా? సో there is a movement of inertia along A axis, right? That is why IA is not equal to 0. If you rotate this molecule through A axis, the positions of 3 hydrogen atoms will change. That is why IA is not equal to 0. Okay, that is one point. Now, see this B axis. B axis. Rotate about this B axis. Imagine just holding this carbon and this hydrogen. Okay, and now rotate this molecule through this B axis. Then this hydrogen atom position will change, this hydrogen position will change, and this hydrogen position will change. So positions are changing. So we can tell IB is not equal to 0. Okay. Now see this C axis. Try to rotate along C axis. అప్పుడేమవుతుందమ్మా, this hydrogen and this hydrogen and this hydrogen will move. So the positions of these 3 hydrogens will change. So IC is also not equal to 0. మీరు 3 యాక్సిస్ లో ఎలా రొటేట్ చేసినా కూడా మిగిలిన 3 హైడ్రోజన్స్ రొటేట్ అవుతున్నాయి. That is why movement of inertia can exist along C axis, along A axis and along B axis. IA is not equal to 0, IB is not equal to 0 and IC is not equal to 0. That is why we can write like this: IA is equal to IB is equal to IC. Symmetrical top molecules. Please observe this molecule. What is the name of this molecule? Methyl chloride. Methyl chloride or chloromethane. Okay. Center of gravity is located at చెప్పండి, where is the
Chlorine.
center of gravity? Center of gravity is located not
Chlorine.
between the carbon and chlorine. Yes, center of gravity is located towards chlorine side. చూడండి మధ్యలో ఏమీ లేదు, కొంచెం పైకే మూవ్ అయింది. సో center of gravity is placed or located towards chlorine side because of high mass of chlorine atom. Okay amma? So whenever you want to identify the moment of inertia or IA, IB, IC axis, first you should identify the center of mass. లేదంటే ఇక్కడ నుంచి మీరు కార్బన్ నుంచి పెట్టొద్దు ఇక్కడ. You should not pass these axes through this carbon. The first condition is you have to identify the center of mass. Then you can imagine 3 axes passing through this center of mass or center of gravity. Okay, now here this is the center of gravity. This is the center of gravity. Okay, this is the center of gravity. Vertical axis is A axis. Okay, this is A axis. Now imagine this, you are rotating this methyl chloride molecule through this A axis. What will happen? You are rotating this molecule through this A axis. A axis prakaram pattukoni ila tipputu unnaru, and you are holding this carbon and chlorine. Along A axis there are 2 atoms, chlorine and carbon, rendu unnai. Just imagine line is passing through chlorine and carbon. So means you are holding carbon and chlorine. The positions of hydrogen atoms will change. That means it has
It is
moment
not
of
equal
inertia.
to 0.
Yeah, there is a moment of inertia along A axis. So IA is not equal to 0. That is why IA is not equal to 0. Now see this along B axis. B axis. Okay. B axis is passing through just center of gravity. B axis is passing through center of gravity. Now imagine rotating this molecule through this B axis. Tipparu. ఏమవుతుంది? The 3 hydrogen atoms and chlorine atom positions also will change. అర్థమవుతుందా? Because this B axis is not passing through chlorine. So chlorine కూడా ఒక పక్కకు ఉంటుంది. ఇటు సైడ్ ఇంకా 3 hydrogens ఉన్నాయి. If you rotate about this B axis, positions of these 3 hydrogen atoms and as well as the position of chlorine atoms will change. కదమ్మా? So అన్ని తిరగాలి. ఇంత ముందన్న క్లోరిన్ అలా పట్టుకొని ఉన్నాం, బట్ along B axis all the atoms are rotating. So IB is also not equal to 0. Next, along C axis. Along C axis same అన్నమాట, similar to B axis, and you are rotating along C axis. ఇలా తిప్పుతున్నారు. Now again these 3 hydrogen atoms and 1 this chlorine atom position will change. So IC is not equal to 0. IB is not equal to 0 and IC is not equal to 0. That is why we can say IB is equal to IC. Okay. In overall, you can write like this. IA is not equal to 0. Okay. Through carbon and chlorine. IA is not equal to 0 and IB is equal to IC. So this is unique rotational axis and IB is equal to IC. Both are same energetic. Kabatti to degenerate rotational axis anochu. And IA is not equal to 0 అనేదాన్ని ఏమనొచ్చు, you can say unique rotational axis. And if IB is equal to IC, that is why we can say them to degenerate rotational axis. Okay amma? It is an example for symmetrical top molecules. Methyl chloride, chloroform, methyl cyanide ఇలాంటివన్నీ కూడా ఇందులోకి వస్తాయి. Symmetrical top molecules. Next, and most important, these symmetrical top molecules are again classified into 2 types. See this, symmetrical top molecules are ante inta mundu ippudu chadavam kada. These symmetrical top molecules are classified into 2 types. One is prolate symmetric top molecules and oblate symmetric top molecules. Prolate ante oval shape or egg shape ila annamata. Okay, and oblate ante pumpkin shape or like this shape. Okay, prolate symmetric top molecules means here this molecule is has prolate shape or oval shape. See, chlorine koncha paiki itla laginattundi kada, so prolate shape. And this boron trichloride, it is planar, but when you rotate through an axis, it will rotate like this pumpkin. That is why we call it as oblate symmetric top molecules. Okay, let us see this prolate symmetric top molecules amma. Same example, methyl chloride. We know that center of gravity at chlorine side, IA is not equal to 0, IB is not equal to 0, IC is not equal to 0. ఇప్పుడే చూసాం కదా ఇక్కడ సేమ్ అదే IA is not equal to 0, IB is not equal to 0 and IC is also not equal to 0. But see here, relation between this moment of inertia, the relation between the three moment of inertia. జాగ్రత్తగా వినండి ఇక్కడ ఒక పాయింట్. You are rotating this molecule through this IA axis, A axis. Okay, you are holding carbon and chlorine and rotating. So moment of inertia is not equal to 0. That is IA. And again, IB and IC. They also have some moment of inertia. IB is not equal to 0. IC is not equal to 0. Here, which moment of inertia is higher? అంటే ఏ రొటేషన్ చేస్తున్నప్పుడు మాలిక్యూల్ ఎక్కువగా రెసిస్టెన్స్ చూపిస్తుంది? అలాంగ్ ఏ యాక్సిస్ ఆర్ బి యాక్సిస్ ఆర్ సి యాక్సిస్? చెప్పండి. మనము ఏ యాక్సిస్ నుంచి రొటేట్ చేస్తున్నప్పుడు 3 హైడ్రోజన్స్ మూవ్ అవుతున్నాయి కదా, కాబట్టి ఇది కొంత రెసిస్టెన్స్ చూపిస్తుంది. దట్ ఈస్ వై IA is not equal to 0 అన్నాం. బి యాక్సిస్ రొటేషన్ చేస్తున్నప్పుడు 3 hydrogens and 1 chlorine atom. అంటే 4 atoms are rotating. 4 atoms positions are changing. So IB is not equal to 0 annam. Now rotation about the C axis. Here also positions of 3 hydrogens and chlorine atom are changing. Now my question is, which moment of inertia is higher than the other two?
IB and IC.
IB and
IB
IC.
and IC.
So rotation about A axis, positions of 3 hydrogen atoms are changing. Rotation about B and C axis, chlorine మారుతుంది and the position of 3 hydrogen atoms also changing. So it need more energy and more resistance. 4 atoms ని తిప్పుతున్నాం మనం, అవి ఇష్టపడవు. So IB and IC show high resistance. That is why IB and IC are moment of inertia is higher than that of IA. So this is the relation for prolate symmetric top molecules. And next, oblate symmetric top molecules. And see this. This is A axis. Here line is passing through boron. Imagine like this, line is passing through boron and you are rotating. If you are rotating through this A axis, the positions of 3 chlorine atoms are changing. Avuna? And imagine an axis passing through in this way, B axis. See, boron, center of gravity boron. So that axis should pass through boron. Boron nunchi velthu just and it is touching chlorine anukondi kasepu. Okay, just imagine like this. And here you can see this image also. And see this is very clear image. See this boron trichloride is, imagine this BCl3 on a plane. Okay, and just imagine line is passing through this only boron, that is A. If you rotate about this axis, the positions of these 3 chlorine atoms are changing. Kadamma, ardhamavutunda ikkadi point meeku. So this is IA. And now imagine here C line. Okay, imagine this line. So left side 2 chlorine atoms are there, right side 1 chlorine atom. Just imagine. And this is C axis and left side 2 chlorines, right, here this side 1 chlorine. So again along C axis also positions of chlorine atoms are changing. Now see this B axis. See this. Here also front side 2 chlorines and other side 1 chlorine. In overall, along A axis, along B axis, along C axis, the positions of 3 chlorine atoms are changing. Ela tippina kuda 3 chlorine lu positions martune unnai. But which moment of inertia is higher than that of other two? Cheppandi.
IA, ma'am.
IA. Okay, IA is higher. Why?
3 chlorine atoms change అవుతున్నాయి.
Very good. See this. IA is higher than that of IB and IC. IB చూస్తే left side 2, right side 1. So it requires less energy. And this IC also, if you imagine this IC, 2 chlorines one side and left chlorine one side. But if you rotate along through this only boron, you have to apply more force. Because at a time you are rotating these 3 chlorine atoms in this shape. So, అంటే దీన్ని ఇమాజిన్ చేసుకోవాలి మనం, ఇక్కడ చూపించినంత ఈజీ కాదు. జస్ట్ ఇమాజిన్ యువర్ సెల్ఫ్. So this IA axis is higher than that of IB and IC. And you can see this figure also. planar molecules like trigonal planar molecules like BF3, BCl3 or oblate type symmetric top molecules. Okay. And the next one, asymmetric top molecules. For example, water తీసుకోండి. ఇది కొంచెం ఇమాజిన్ చేసుకోండి జాగ్రత్తగా, then only you can understand this one. When all the three moments of inertia are unequal, IA is not equal to 0, IB is not equal to 0, and IC is also not equal to 0. But here we are not showing this as ఇలా చూపించట్లేదు. చూడండి డిఫరెన్స్ అన్నిటికీ, దీనికి డిఫరెన్స్ ఏంటంటే IA is not equal to IB. Okay. And IB is also not equal to IC. అన్ని వేరువేరుగా ఉంటాయి. But here we are not saying like this is equal to 0 అనట్లేదు, and we are also not saying like this not equal to 0 అని కూడా అనం ఇక్కడ. ఎందుకంటే there is a variation in each and every moment of inertia. See this, IC is greater than IB, IB is greater than IA. These moment of inertia are not equal. So when all the three moments of inertia are not equal, such molecules are called asymmetric top molecules. See this, elamari. For example, water. This is oxygen and these are two hydrogen atoms. And see these images. Here you can see. This is rotation about C axis. Okay, this first one is rotation about C axis. Ante ee dot in the blue dot, you are just passing through an axis along this oxygen atoms. Chudandamma, and you are rotating this side. Ante enti this axis may divides this water molecule into two equal parts. Avuna, left side hydrogen and right side hydrogen. See, this is the axis. మనం ఇక్కడ లైన్ చూపెట్టట్లేదు, యాక్చువల్లీ ఇట్లా వెళ్తున్నట్టుగా ఒక రకంగా. అండ్ ఇమాజిన్ దిస్ C యాక్సిస్ ఓన్లీ త్రూ దిస్ ఆక్సిజన్. మన వైపు నుంచి అలా ఒక లైన్ పంపిస్తున్నాం అనుకోండి, అండ్ యూ విల్ సీ వన్ హైడ్రోజన్ లెఫ్ట్ సైడ్ and one hydrogen right side, and you are rotating in this direction. So the positions of hydrogen atoms will change. So there is a moment of inertia. And next one, B axis imagine cheskondi. B axis is just upside nunchi veltundi, down vastundi, pai nunchi kindiki pampistunnam. Imagine passing through oxygen atom, center of gravity. Here also you are rotating and the positions of hydrogen atoms are changing. Okay. And in the case of A axis is passing through oxygen atom nunchi veltundi, but these oxygen and two hydrogen atoms will be in the same plane when you are passing through A axis. Ila pampistunappudu you will see all the atoms are in a same plane. Okay, line lo unnayamma. See them. This is C axis. You are rotating in this way. Okay, positions of hydrogen atoms are changing, but at a time one side two hydrogens are there in this case, and in this case just up to down, and left side one hydrogen, right side one hydrogen. So the ante a weight takkuva padutundi anukundam kasep. So this is B, and here you are passing an axis through in this way. So the hydrogen atoms and oxygen atoms are in the same plane, so it requires less energy. So moment of inertia order will be like this: IC is greater than IB, IB is greater than IA. This a little bit complex ఊహించుకోవడానికి. So this type of molecules are called asymmetric top molecules. Okay, there is no preferential direction, and any of the ABC can be used as a preferential direction. అన్ని తిరుగుతున్నాయి, but there is a slight variation. Okay, so that is why they are not equal. This type of molecules are called asymmetric top molecules.